In the preceding video, we looked at the first two stages of the business intelligence project, of a business intelligence project, being obtaining the data, then extraction, transformation, and loading. This video will look at the next two stages, obtaining the data store, and then querying and reporting. So the idea of a data store is once you've got the data, you put it together, you put it all in one consistent format, put it in one place. This classic approach to this is a data warehouse, which is one large database with all the organization's integrated data. And that means both external and internal data. A data warehouse is designed for analysis, which means it's optimized for rapid and complex analysis. Now, if you're familiar with an enterprise system, that's another kind of database that has all an organization's information in one place and maybe also some external data. But a data warehouse is very different from the database of an enterprise system because an enterprise system is an operational database. It's designed to receive transactions by the second or even microsecond and keep everything up to date. All the information is real time relevant. But technically, in the technical configuration of a database, that is very different from an analytic database like a data warehouse that does not have real time updated data. At the most, a data warehouse might have data updated every night. So that as of today, once you want to do the analysis, all the data is current as of yesterday, and you can look at everything in the past. But it's not a second by second up to date because that has different technical implications. So you can't use the same database for both. Now, as I said, the ideal case is you have a data warehouse with all the organizational information in one place, but uh, most of the time you don't have the ideal situation and you have a smaller subset of the organization's data, which is called a data mart. And here, data mart, instead of being the entire organization, represents only maybe one department or one office location. And reasons for this are that it's often not feasible to collect all the organization's data. Sometimes all the organization's data is just too large. You might have gigabytes and gigabytes of data, and it's too computationally intensive to analyze. But more often than not, the issue is that it's just not practical to gather all the data. And a lot of times, because if maybe you're a marketing manager, perhaps the human resources managers are not willing to give you personal employee information for you to do your analysis with. And maybe you, as a market manager, you would like to get inventory data, and sure, they'll give it to you, but maybe only every month or so, whereas you would like to have it every day. And so, just because of these organizational infeasibilities, you have to settle with just one department or one office location. So, as a marketing manager, you might be able to deal with marketing, or maybe you are the Paris branch manager, and okay, you can't, because you're the branch manager, you can get all the information from everything in Paris, but you can't get information or all the information you would like from your Lille branch or your Sophie Antipolis branch. So you just settle with a data mart. So the difference between data warehouses and data marts is just in the scope of the database, but in functionality, they work exactly the same way in the analysis that follows. Now, again, speaking of having databases of this enormous size, there are issues and challenges involved which might require sampling of data. So when you have big data in the sense of high volume, the most typical sense of big data, sometimes it's just too large. It's too much to practically do the data mining analysis that you would like to do. Uh, so it's typical to just take a smaller subset. Uh, so not all the data that you have, like maybe you potentially could have 10 million rows of data, but maybe you just take 10,000 rows of that, for instance, which is a much smaller subset. So that's 10 million versus 10,000, that's just 0.1%. And you can do this because of statistical properties, the fact that uh, properly sampled data, if you do it properly, when you have just a few thousand records, then it is sufficient to build a good model that can reflect the full larger data set. One of the reasons you have to do this is that some computing intensive models are easier to work with when the sample is smaller. So there's some models that if you go from, let's say, go from 1,000 lines of data to 10,000 lines of data, okay, it'll run 10 times longer. But there are some that the increase in computing time is exponentially larger. So, for instance, maybe to analyze 1,000 lines of data, it takes 1 second. But if you increase it to 2,000 lines of data, it takes 10 seconds. If you increase it to 3,000 lines of data, it takes 100 seconds. If you increase it to 4,000 lines of data, it takes 1,000 seconds. And suddenly, when you have even your 10,000 lines of data, it's taking you more than an hour just to run one algorithm that you'll then need to adjust. And so when you're dealing with algorithms like this, you might really need to sample your data to cut things short. Another practical restriction, if you're using a tool like Rapidminer, the free version of Rapidminer, if you don't have the funds for a full license, the free version is capped at 10,000 rows of data. And so if you want to work within that free version, you might need to sample your data in order to work within those limits. The good news is that as long as your sample is truly representative and random, then the models derived from your sample can reflect the entire data set. But it needs to meet these two conditions. Representative means that every major aspect of the full data set, let's say the 100 million rows, is represented in your 10,000 rows. So, for instance, you have the same proportion of male and female. Maybe you have customers of different income categories. Each income category is represented in your sample in the same proportions. If you have people that live in different regions, each region that matters is represented in the same proportions. So that's what representative means. And so it needs some work to make sure that that occurs in your sample. And it needs to be random, meaning that once you have someone within the category you want, everyone has an equal chance of being picked. It's a truly random sample, at least stratified within the category that you want. So as long as you meet these conditions, then your sample can reflect a much larger data set. So once you've got the data store, and if you decide to sample it or you use the full set, you can come to the fun stuff of the analysis, which is the querying and reporting. This might involve data analytics, which generally is aggregation, summarization, computation, data mining, which is a major focus. And this is a process of automatically discovering non obvious relationships using statistical or machine learning techniques. There's monitoring and alerting, which is not necessarily you're trying to discover new things, but you're trying to display selective information, especially highlighting numbers when they are too high or too low, when they cross a certain threshold. So, for instance, yes, you know you have to buy inventory restock, but you're waiting until and you might have regular monthly purchases, but you want to know when the exchange rate from the country that you're buying from suddenly becomes very favorable, and then you make a major purchase there. You don't wait for your monthly time. So that's an example of an alert. There's data visualization, which involves creating tables and charts for visual summaries and exploration of the data. Now, these are the main things we think of when we talk about business intelligence. And this is the fourth stage of the process. But it's very important to understand that the first three steps, which are the data preparation, can take up or typically take around 80% of the time. And this number is something that's been borne out in many surveys of data analysts, that the preparation, getting the data ready for the analysis, which is usually what you really want to do, takes 80% of the project time, and the actual analysis is only 20% of the time. On one hand, that can be frustrating, but if you know that, and if you know that that's normal, then it shouldn't be frustrating. You realize you need to invest that 80% of preparation time so they can have clean, uh, relevant data that can then finally give you the insights that you're looking for. And so there we have the four steps of the business intelligence process and the data preparation that leads up to them.